Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us discuss today's overview. In this overview, we will be discussing about one of the techniques in sorting, that is insertion sort. We will be discussing about the insertion sort, what is insertion sort and its introduction. Then followed by insertion sort algorithm. Then we will be seeing the example of insertion sort. And at last, we will be see the implementation of insertion sort also. Okay. We will be seeing all these things in today's session. Let us go for the introduction part of insertion sort. Yes, let us see here. Insertion sort is an in-place sorting algorithm. In place means suppose we have taken some array elements which are not in the sorted order. Okay. I have already have some elements 7, 3, 5, 2 like this. I am going to take one element, new element as 1, where I am going to in place or insert, or if I am going to take the element 2, suppose this element I need to place, where I need to place it, I need to place in between 7 and 3 if this is the case, right. Like this way, if I am going to place or insert some element in between or before or after, if I am going to do this, that is nothing but an insertion sort technique where we are going to apply. But here it uses no auxiliary or data structure while sorting. Here we are not going to take any extra data structure, buffered data or buffered memory we are going to use, right, while performing the sorting. It is inspired from the way in which we sort playing cards. This insertion sort has been taken from the real-time example of how we are going to go with the playing cards, right. We all know that what are the playing cards, how many cards it consists of, and while playing, how the people are going to place a particular order, that is cards are going to be placed in the particular order. Based on that technique, this insertion sort algorithm has been developed. Okay, and the list here, the list is divided into 2 sublists, or one is of sorted and another one is of unsorted. And based on that, we are going to place the elements which are in unsorted, that is going to be placed in the sorted order. Okay, and in each pass, the first element of the unsorted sublist is picked up. From the unsorted list, we are going to pick up and transformed it into sorted sublist by inserting at the appropriate place. I told you, right, we are going to place the element in the appropriate place. That's why it is called it as insertion sort. Okay. Let us go with the insertion sort algorithm. See the steps, and afterwards we will see one example so that you could understand clearly. We have to start with the second element of the array, as the first element in the array is assumed to be already sorted. Suppose if I want to perform sorting in the first, if you could listen for the bubble sort, we are going to start checking the adjacent elements from the first and second. First 2 elements we are going to compare, but here we are not going to compare the first element. First, if I am going to take one card, that is the first card which I am going to take. I don't need to have any comparison. Directly I am going to place as it is. That's why we are not going to check from the first element. First element, whatever you have, you place as it is. and start checking from the second element, right? Now compare the second element with the first element. Already you have one element already present. If I am going to take, you consider some 5 cards I have placed. First card I have taken, that first card is having some element, and with the first card I no need to have any verification, directly I am going to place as it is. And if I am going to pick the second card, now I need to do the comparison. Why? Because already I am having one card. Now compare this one with the second card. Okay. Now based on that, what you are going to do, check if the second element is smaller, then swap them. What is the first card you are having, and you have taken the second card. Now compare it. If the second element is smaller than the first one, then we are going to swap them. That means you are going to place the second card into the first place. Otherwise, you are going to place it in the third place, the same place only. Okay. Move the third element and compare it with the second element. Right. Suppose if you have the third element, then you are going to compare it with the second element, then the first element, and swap as necessary to put it into the correct position among the first 3 elements. Suppose if you have 3 elements, right? Suppose you have taken the second card, compare it with the first and place accordingly. Otherwise, if you are going to have the third card also, then in that particular case, you need to compare this with the first one as well as with the third one. Both the things we have to do. According to the condition, you need to place whether before the first card or after the first card or after the second card. That is after the third card or before the third card. Based on this, we need to check for all the cases, not only comparing with the first one, right? Continue this process comparing with each element with the ones before it and swapping as needed to place it in the correct position among the sorted elements. Yes. If you are going to have some 3 cards, okay. Now consider, suppose I am going to have 5, 2 and 1. These are the 3 elements. You consider these are the 3 cards where you are going to have. Suppose I am going to pick the first card 5. Yes, that is the first card I am having. Directly I am going to place it in the sorted order. And no need to have any comparison, just the first, that is the first element. I am going to place as it is. Now I am going to take the second element. Now in this case, what we need to do, we need to make the comparison. Now I am going to compare 2 with 5. Yes, 2 is smaller than 5. Now where I need to place this 2? Actual position. The position of 2 is before 5. That has to be inserted before 5. That means we need to get 2 and 5. That means we need to make the comparison and we need to move that element to the first position, and the first element has to move to the second position. This has to be done. According to this, we need to write the logic. Now you have got this. Now I am going to have the element 1. Whatever the next card I am going to take is 1. Now what we need to do? Now this has to be compared with the second element. There itself we should not stop. When comparing with the second element, what happens? It should be coming under here. But is it the right place for placing 1? No. Again, we need to compare this 1 with the 2. Right? The right position for 1 is 1, 2 and 5. The first position it has to be placed. That's why we need to compare until the first element. Up to the first element we need to compare. This is the procedure where we are going to follow. According to this, we are going to write the logic. Right? Repeat until entire elements is sorted. If I have here, for example, I have taken 3 elements to understand you better. In the same way, if you have given some elements, until all the elements to be getted in the sorted order, we need to repeat this process. Right? Like this way, this procedure is going to work for the insertion sort. Now take the example and see how this is going to be, insertion sort is going to work. These are the 5 elements. For easily understanding, I am taking 5 elements. Okay. In the first pass, we are not going to do anything. Why? Because the first element is the first element will be there. You don't need to have any comparisons. Directly we are going to have the first element will be there in the first position only, right? Like this way. Like this way we have, right? Now in the second pass, what happens? I am going to consider my second element is 1. Now this 1 is going to be compared with 23 and 1 is less than 23. Because of that, we need to swap these two elements. That is 1 and 23 are going to be swapped, right? Now 1 is at this position and 23 in the second position. This is the second pass. And in the third pass, consider my third element is 10. But what is the actual position of 10? 10 should be, if I am going to take 1 and 23, what is my actual position of 10? It should be in between 1 and 10. In the same way, here also we are going to do. That is, 10 is going to be compared with the 23, right? 10 is going to be compared with the 23, and based on that, we are going to place the element 10 in between 1 and 23, right? First, now directly we are not going to place it. First, we are going to compare with the 1 and then with the 23, and according to that, we are going to insert. Directly, we are not comparing with the second element. First, we will be going to the first element and then comparing with the second, and then based on that, where its position is suitable, there we are going to place that one, right? So that we are going to get 1, 10 and 23. And the fourth pass is, I am going to have the element 5. Now, which is the right position to place 5? The right position is 1, 5, 10 and 23, right? In that particular position, we are going to insert. Again, we are going to do the comparison from the first onwards, right? And the last element where we have is 2. Where is the correct position we need to place it here? According to this list, 2 comes after 1. That's why we are going to place it in the sorted order. This is the sorted order where we are going to get it. Let us see the insertion sort algorithm and some important points where you need to remember. Insertion sort is not very much efficient algorithm where data sets are large. When you are going to have the small data set, it is very easy to compare from first, second, third onwards. But if it is a large data set, then it is a very time taking process. And this is indicated by the average and worst case complexities. If you are going to see the average and worst complexities of insertion sort, it will be taking of big O of n square. The time complexity is more for this, right? And insertion sort is adaptive and number of comparisons are less if the array is partially sorted. If whatever the array you are going to take, if it is already partially sorted, then the number of comparisons will be reduced. It will be less, right? Otherwise, it will be taking lot of time. That means it will be based on the number of loops. We are going to have 2 loops are there. Because of that, it will be taking n into n. Number of times the loops has to be repeated to sort the elements in the sorted order. And if you can see the algorithm for insertion sort, how this is going to work. This is the algorithm, or this is the method or function where you can write how this insertion sort is going to work. And if you can see the time complexities of insertion sort here, for if the list is already sorted, it will be taking big O of n. For average and worst cases, it will be taking big O of n square. Okay. And before going to show you the implementation part of it, I want to tell you how this insertion sort is going to work. Let us take with the same example what we have seen up to now. What are the elements we have? 23, 1, 10, 5 and 2. 23, 1, 10, 5 and 2. This is your array actually. Let us see for few steps I will tell you how you need to trace it out. And these are the indexes of it. Okay, and here key equal to array of I. I is nothing but 1 here. I starts from 1 onwards. Why? Because we are not taking the first element for comparison. That's why we are initializing I equal to 1. Now take first start I equal to 1. That is the first, this is the element where we are going to take, and assign that array of 1 value to key. That is, what is your key value now? Key equal to, key is going to be stored with a array of 1. That is nothing but array of I is nothing but the 1 value. Now key value is 1. Now j will be decremented. That is, j becomes I minus 1. What is your I value is 1. 1 minus 1 is nothing but 0. Now j value is 0. Now enter into the while loop. Now check for the condition. What is your j value? J value is 0, greater than or equal to 0. The condition is true. And array of j, what is your array of j? J value is 0 is greater than key value. Key value is 1. What is present in a of 0 value? A of 0 value is 23. 23 greater than 1 is the condition is true, and 0 greater than 0 is also true. Both the conditions are true, right? Both the conditions are true. If both conditions are true, then what we need to do? We need to perform the swap of it. That is, a of j value is going to be placed in a of j plus 1, right? A of j value is how much? A of j value is nothing but this one, 0 value. That one we are going to place it in a of j plus 1. That is, here we are going to place 23. Now j will be again minus 1. That is, j equal to j minus 1. Now what is your j value? J value is already 0. 0 minus 1 is nothing but it is minus 1. Now if you are trying to iterate this loop, right? If I am trying to iterate this loop, this condition will be failing. What is that condition? J value is minus 1 greater than or equal to 0, and this condition, a of j is nothing but a of, what is the j value now? Minus 1, we don't have any value. Otherwise it will be taking the value as default value as 0. 0 greater than key value is 1. Here itself the condition fails. Now because of that, this loop will be terminated. After terminating this loop, what we are doing? In array of j plus 1 equal to key, array of j plus 1, what is j now? J becomes minus 1. Minus 1 plus 1, that is nothing but j value now it is 0. In a of 0 value, we are going to place the key value. What is your key value? Key value is nothing but 1, whatever already we have stored here. That one is going to be coming into this a of 0 value. Now observe here, previously it is 23 and 1, now it becomes 1 and 23. Like this way we are going to perform the swapping, that means, or inserting we can say, right? This is how the insertion algorithm or logic is going to work. I have given for one iteration, you can try for the second iteration so that you could understand how this 10 is going to be inserted in between 1 and 23, right? I hope you understand this one, and let us see the implementation part of part in this insertion sort. Why? Because the same logic we are going to write instead of in the main function will be the same, and only this insertion logic we are going to write them separately. Let me show you this in the online GDB compiler, and then we'll see the execution part also for that. Let us have this insertion sort. Yes, already we have the code here. Let me open. Yes, this will be the similar one where you have returned this in your bubble sort also, the same logic. Array reading, size of array reading, array elements will be readed, and we are going to have before sorting what are the elements we have and after sorting what the elements we have. But in between that we are going to call this function. insertion sort function we are going to call, right? And this is a logic already we have seen in our program, previously algorithm, whatever we have written, the same thing is there. Now try to execute this one and see how this insertion sort is going to work. Let us take here, enter the array size. Suppose I have taken the elements as 5. Yes, give some 5 elements. Suppose take the same elements 23, 1, 10, so 5 and 2. Enter. If you could see here, these are the elements which I have inserted before sorting, and after sorting all the elements are in the sorted order. Okay, like this way it is going to work. Now let us come to the summary of our insertion sort. Yes, what we have seen in this session. In the insertion sort, we have seen about the introduction about the insertion sort, how the logic or what is an insertion sort we have seen. The difference between, now you could understand the difference between the bubble sort and the insertion sort. And we have seen the insertion sort algorithm and how this insertion sort algorithm is going to work. That is, how we are going to place a particular element in the correct position if it is of unsorted. Then example also we have seen, we have taken a list of elements, and some part is we are going to take at the starting, we do not have any sorted elements. The first element will be considered as the sorted element, and the remaining elements, if you are going to get, those elements are going to be placed in the appropriate position, right? According to that, we have seen an example with the different passes also. Then we have seen the implementation part of insertion sort, and we have seen the logic, how it is going to work with the insertion sort, and how we are going to swap them, or we can say it as how we are going to insert the element in the proper position. These are all the concepts where we have looked into the insertion sort, and from this you can understand how the bubble sort logic is going to be differed from the insertion sort. And these are time complexities for bubble and insertion sort are more. Because of that, we are going for the further sorting algorithms. Okay, those sorting algorithms we are going to discuss in the next session. I hope you understand this and you can able to try to practice the programs which I have been explained. Okay, thank you.